So in this lecture, so the first question is, what is biology? If you break down the word biology, bio means life, and that being the study of. So biology is a science that studies living things and living processes. That being the case, what is science? Science is the study of the world through observation and investigation. So specifically in this class, we will be studying life through observation and investigation. So first lesson this year is we're going to learn some of the basic skills that I hope you guys will apply for the rest of the year. So science is methodic. There's a method to it. There's an order of procedure. There's an order of events that you need to follow in order to discover and to explore more in science. And it relies on observation, whether it be a simple observation or a much more complex observation, whether it be some kind of physical reading you're taking or something you're just observing with the naked eye, all of which requires observation. So what is the scientific method? This is something you've been studying since you were a young child, and albeit the steps themselves may not follow the exact wording, when all is said and done, it follows pretty much the same process. And the first step being to identify the problem or the question. It helps to know what exactly you're studying before you seek to study it further. Then the next step is to make observations, some of which could be direct. A direct observation is anything that you make just with your own senses. So you can look at something and tell that it's blue. You can feel that something is warmer than something else. You can tell that something is taller than something else. But an indirect probably gives you more information because it requires tools. You can't tell necessarily that one person is exactly 6 feet 3 inches. You'd need a ruler or something thereof to measure that. You can't tell exactly what temperature something is, even though you may ballpark it, but you can never tell that something's exactly 72.5 degrees, for instance. And then you make a hypothesis, which I'm sure you guys know is an educated guess. And you can't just rest on a hypothesis. You need to take it a step further, and you need to test the hypothesis, which is really what science is often all about. Any science fair project you've ever done is primarily testing a hypothesis that you've had. You can't just say something is the way it is. You need to actually test and acquire results and then analyze those results to verify whether the hypothesis is true or not, which leads us to the last step, which is to accept it because your results seem to indicate the hypothesis is correct. Change it because perhaps the hypothesis is not correct, but with some alteration, if you will, then it could be correct, or correct perhaps in a different scenario or under different conditions, or discard it altogether because the hypothesis is not correct nor indicates whatsoever that it will ever be correct. So if you are going to test a hypothesis or test an experiment, we're going to use this example in this class. So Timothy buys new sneakers that he believes will make him run faster. We're constantly being bombarded with advertisements that some kind of athletic product will make you run faster, jump higher, hit the ball further, you name it. And he times a run in his old sneakers that he's been running in all along and compares it to a timed run in his new sneakers. And he notices that he only ran slightly faster in his new sneakers than in his old sneakers. So in any experiment, for instance, just like this one, there must be at least two groups. All right, we'll look at that. One of which being a control group, or experimental group, one of which being the control group. There must be constants that we'll be talking about, and there must be an independent variable, and there must be a dependent variable. So to define them, a constant is anything or any factor in an experiment that is identical in all the groups. Whether there's 2 groups, 3 groups, or more, they are factors that are completely identical in every single group. Then there's the independent variable, which is any part of the experiment that is made different because of the different groups. Between the different groups. So something that the experimenter, perhaps you, physically controls and makes different between, let's say, group 1, group 2, or group 1, group 2, group 3. Something that you physically change. Then there's the dependent variable, which is any kind of result. It's a part of the experiment that changes because of the independent variable. So if you think about it, if you make something different between your 2 or more groups, the dependent variable is what's going to happen because of that. And we're going to look at that with our little experiment with Timothy. And then there's the control group. So one of the groups should be the control group. And the control group is the one that receives no new treatment and often creating a predictable result. Some say that it does not receive the independent variable or receives a predictable version of that independent variable. And the experimental group is the group that receives, or groups rather, that receives new experimental factors that create unpredictable results. Results that you might, well, let's say you might predict them, but you are not 100% correct that they will actually turn out that way. It's the group that there is a level of uncertainty as you begin experimentation. So let's go back to our example here with Timothy. In this experiment, what is the control group? And again, the control group is the predictable result or predictable group. It's a group that doesn't receive any new treatment, but it's there primarily for a frame of comparison, and that would be the time in which he runs in his old sneakers. He's been running in his old sneakers all along. He shouldn't, expect to run any faster or slower than he ever has in his old sneakers, but he uses that as a comparison against the experimental group, which again is the new, the unknown. It receives the new factor, or if you will, the newer version of the unknown version of the independent variable, and that is when he runs in his new sneakers. So again, he's never run in his new sneakers. He isn't quite sure. They might even make him run slower for all he knows, but he compares his experimental group to his control group. And it's important that both of those exist because he can't just go out and say his new sneakers make him run faster unless he has that comparison between that and his control group, his old sneakers. So what is the independent variable? What's the one difference that he makes certain exists between the experimental and the control group? And that would be the sneakers. Everything else should be the same. Everything else should be, as we'll discuss in a minute, constant. But the type of sneakers he's wearing should be the one difference between his two runs, and the dependent variable is the result. It's what happens because he is wearing different sneakers. It's what happens because of the independent variable, and that is, in this case, that he ran faster, slightly faster in his new sneakers, or that he ran slower in his old sneakers. And again, if everything else is constant, then he can say that it is because of his new sneakers that he runs faster. And if everything else is identical, then he can comfortably say that. If there's even one thing that is different, then he needs to redesign his experiment and retest it. So thinking of constants, what are some things that should be identical between both the experimental group and the control group? And examples kids commonly come up with is that he should be running on the same surface, he should be running the same distance, he should have the same amount of energy each time he runs, he should be wearing the same clothes. If you think about it, if he's wearing a tracksuit one time and jeans and a winter coat the next, that very likely could cause a difference. He should be equally hydrated. He should have eaten a similar diet beforehand. The weather should be the same. You might run slower on a wetter surface or with less traction or with wind, for instance, if it's at your back or in your face, that could ultimately affect how well and how quickly you run. So every factor should be the same. Every factor should be constant, except for the type of sneakers he's wearing, the independent variable, which will lead to the dependent variable, a change in speed ultimately, between the experimental group, his new sneakers, and the control group, his old sneakers.